Hello students, welcome to IIT Chemistry online classes. In this presentation, I will explain the Appel reaction including its mechanism, stereochemical outcome and scope, followed by examples and practice questions. Before we proceed further, I would like to inform you that practice questions along with the answer key will be provided to help you revise and strengthen your understanding. Please follow the instructions displayed on the screen to access them. Let us now begin with the general representation of the Appel reaction. The Appel reaction involves the conversion of an alcohol into the corresponding alkyl halide using triphenylphosphine and a suitable halogen source. Carbon tetrahalides are commonly used as a source of halide ions. In addition, bromine can serve as a source of bromide, while methyl iodide or iodine can be used as sources of iodide. Now let us go through the mechanism part. Initially, the triphenylphosphine abstracts the halide ion from carbon tetrahalide, leading to the formation of a tight ion pair consisting of a halotriphenylphosphonium ion and a trihalomethyl anion. The trihalomethyl anion CH3- is a strong base, and hence it abstracts a proton from the alcohol, leading to the formation of an alkoxide ion and trihalomethane CHX3. The alkoxide ion then attacks the halotriphenylphosphonium ion, displacing the halide ion. And finally, the free halide ion, which is acting as a nucleophile, undergoes nucleophilic substitution on the alkoxy triphenylphosphonium ion. This leads to the formation of the corresponding alkyl halide along with the triphenylphosphine oxide. It is important to note that the formation of a strong P double bond O is the driving force of the Appel reaction. This final nucleophilic substitution step may proceed via either an SN1 or SN2 pathway depending on the nature of the alcohol. In the case of primary and secondary alcohols, the nucleophilic substitution follows an SN2 pathway. For secondary alcohols possessing an asymmetric alcoholic carbon, inversion of configuration at the alcoholic carbon is observed. In contrast, tertiary alcohols undergo nucleophilic substitution via an SN1 pathway. As a result, if the alcoholic carbon is asymmetric, the corresponding alkyl halide is formed as a racemic mixture. Let us now see how the SN2 mechanism proceeds using animation. In SN2 pathway, the halide ion attacks the alcoholic carbon from the opposite side of the leaving group. As a result, inversion of configuration occurs at the alcoholic carbon. Now let us see how the SN1 reaction occurs. Initially, a planar carbocation is formed. Now the carbocation is attacked by the halide ion. The halide ion may attack the carbocation from the top face, or it may attack the carbocation from the bottom face. leading to the formation of a racemic mixture. These two are mirror images to each other and are formed in 1:1 ratio. Let us now go through a few examples. In this reaction, geraniol is converted into geranyl chloride using carbon tetrachloride and triphenylphosphine. Carbon tetrachloride acts as the source of chloride ions. Since the reactant is a primary alcohol, the reaction proceeds via an SN2 pathway. However, no observable inversion of configuration occurs because the alcoholic carbon is not a stereogenic center. The synthesis of brasilinine is one of the best examples of the Appel reaction. In this version of the reaction, tri-N-octyl phosphine is used instead of triphenylphosphine. The starting alcohol is a secondary alcohol and is asymmetric. Therefore, the reaction proceeds via an SN2 mechanism leading to inversion of configuration at the alcoholic carbon. In this example, iodination is carried out using iodine and triphenylphosphine in the presence of imidazole. Imidazole assists the reaction by acting as a base and neutralizing the proton released from the alcoholic group. Now test your understanding by answering a few questions. The first question is, which of the following statements is incorrect about Appel reaction? 4 options are given. Option A, it involves nucleophilic substitution. Option B, the driving force of the reaction is formation of a weak P double bond O. Option C, it involves inversion of configuration when asymmetric secondary alcohols are used. Option D, triphenylphosphine is oxidized to triphenylphosphine oxide. Choose the correct option and post in the comment section. Now this is the second question. Which of the following alcohols undergoes the Appel reaction via an SN2 mechanism with inversion of configuration at the alcoholic carbon? Option A, ethyl alcohol. Option B, isopropyl alcohol. Option C, tertiary butyl alcohol. Option D, secondary butyl alcohol. Choose the correct option and write in the comment section. This is the third question. You have to choose the major product expected in the following reaction. This is an Appel reaction on an alcohol. The given alcohol is asymmetric at the alcoholic carbon. Write the correct option in the comment section. That's all for now. Visit adichemistry.com for more information on this topic or search for Appel Adi Chemistry.